Hello, namaste. Today we are going to study about static routing. This is the part of routing protocols and concept. And in this chapter, we are going to study about general role a router plays in a networks. Similarly, describe how the directly connected networks and different router interfaces work. Examine directly connected networks in the routing table and use the CDP protocol. Describe static routes with exit interface. Describe summary and default route. Examine how packets get forwarded when using static routes and identify how to manage and troubleshoot static routes. So if we move forward, then we can find the general role of the router. The function of a router is to select the best path and forward packets to its destination. Introducing the topology, here we have three routers, each of 1800 series connected by a WAN link. Each router connected to a LAN represented by a switch and a PC. Okay, this is the PC and the switch, and it has its own network. For example, this R1 has a 3.0 and 2.0. Similarly, R2 has a 3 network 2.0, 1.0, and 192.168.1.0, and R3 has a similarly 2 network 192.168.0, 192.168.2.0. Connection of a router for a WAN. A router has a DB60 port that can support a 5 different cabling standards. So we have here a DB60 port that can support up to 5 different cabling standards. A connection of a router for Ethernet. So we have two types of connection. One is a serial connection, which is a DB60, and another is a router with the Ethernet connection. Two types of connector can be used: straight through and crossover. Straight through is something we use to connect different types of devices like switch to router, switch to PC, hop to PC, and hop to server. Whereas the crossover is used to connect the similar type of devices like switch to switch, switch to hop, hop to hop, router to router, router to server, and some similar kind of devices. Okay, and interfaces, so we can use these commands to view router interfaces. Like show IP router command is used to view a routing table. Show interfaces are used to show status of an interface. So IP interface brief command is used to show a portion of the interface information. So running config is used to show a configuration file in a RAM. To configure the Ethernet interface, by default all serial Ethernet interfaces are down. To enable an interface, use the no shutdown command. So we need to release a no shutdown command so that the interfaces will be enabled. By default, these are all shut down. Okay, so if we look at here the show IP route, we don't have any route currently configured in the R1. So verifying the Ethernet interfaces, show interfaces for fast Ethernet 0/0. If we want to verify the interfaces, then we can use the command show interfaces for fast Ethernet 0/7, which is used to show status of fast Ethernet port. So IP interface brief, so running config Ethernet interfaces participate in ARP. As you know that each interface is assigned with an IP address, and each IP address has its own MAC addresses. So if we see here, if we use the show interfaces faster than 0/0, then it has its MAC addresses and it has its IP addresses. So ARP is just the address resolution protocol where IP is mapped to a MAC address. We are verifying MAC address and Ethernet interfaces. Configuring a serial interface, interface configuration mode, then enter in the IP address and subnet marks, enter the no shutdown command. So the things that we have already said here is similar like this. So if we check the serial interface with down down, we have show interface serial 00/0. Administrator down, protocol line is down. Serial interface is down and down, even though it has IP addresses was enabled with no shutdown command. physically connecting a WAN interface. A WAN physical layer connection has sides, data circuit, terminating equipment, data terminal equipment (DTE). This is the service provider. CSU DSU is a DCE device. Okay, so data circuit terminating equipment is a service provider. For example, if we have some enterprise equipment here and it has a connection to the ISP, then uh, ISP use the DC, whereas DT is typically router in some LAN. Okay, data terminal equipment. Configuring a serial links in a lab environment. One side of a serial connection must be considered a DC. This requires placing a clocking signal. Use the clock rate command. Interface serial/0, clock rate 64,000. Serial interface require a clock signal to control the timing of the communication. Okay, this is the reason we use the clock signal or the clock rate in a serial interfaces to control the timing of the communication. Similarly, routing table and the CDP protocol. The purpose of the debug IP routing command allows you to view changes on the router performs when adding or removing routes. Example, debug IP routing. IP routing debugging is on. To configure an Ethernet interface, interface fast Ethernet 0/0 IP addresses 172.116. So this is how we will do it. If we still look at here, there is no any IP route shown because we have not added something else. We just are configuring the interface of a router. When router only has its interface configured and no other routing protocols are configured, then the routing table contains only the directly connected networks. So we have in this router we have configured all the interfaces, so it has only a directly connected networks. Only devices on the directly connected networks are visible in this topology. Only these are visible. Okay, so only devices on directly connected networks are reachable currently. We can see the routing table and CDP protocol summary of the interface status with SU IP interface brief. So if you check out the SU IP interface brief, then we can find what are the IP addresses assigned to each interface. So routing table has no roots. As you can see here. So if we check the running config, we cannot find something configured. So we will configure here serial. Okay, interface serial is clock rate, no shutdown, interface fast Ethernet, IP address, no shutdown, interface serial, no shutdown, IP addresses. Checking each route in turn the ping command is used to check end-to-end connectivity. So how to check the connectivity from this PC to PC3 is that we release a ping command, okay, to check the end-to-end connectivity. Yes, if so IP route, then we can find in this router R2 that it has all the directly connected network 1.0, 2.0, and 192.168.1.0, which have its exit interface. Exit interface is something of its own router. Destination IP address first route in the routing table is 192.168.3.1. 3.1, that's a no match. Destination IP address 172.168.3.1. Second route in a routing table is 1.0. Destination IP address 172.168.3.1. So 172.168.3.172.116.3, which is the 3 network. Okay, this is the 3 network. If it has to reach to 172.116.3.0, then it has to go to 172.116.1.0 network. Mm. Okay, so if R2 will ping to the 3.1, then mm, okay, let me check it. First route in the routing table is 1.0. Um, so routing table and CDP protocol propose of a CDP, a layer 2 Cisco proprietary tool used to gather information about other directly connected Cisco devices. So in directly connected Cisco devices, it uses a proprietary Cisco tools to gather information. Concept of neighbor: two types of neighbor, layer 3 neighbors and layer 2 neighbors. So we will have a layer 2 and layer 3 neighbors of each router. So CDP neighbors command displays the following information: is the neighbor device ID, local interface, hold time value in second, neighbor device capability code, neighbor hardware platform, neighbor remote port ID. So CDP neighbors details command useful in determining if an IP address configuration any error. Okay, through CDP we can find this information. To disable the CDP globally we can use the following command: no CDP run. Manually configure route used when routing from a network to a stop network. So we can use a static route to be this is, for example, this is a stop router, and it has to go to a stop from by stop network. Then we can use the static route. Okay, so if this is the stop router, then we can use the static and the default routing here. IP route command: to configure static route, use the following IP route. IP route network address subnet marks and IP addresses. We can use IP route network mask subnet marks and exiting interface and the next hop IP addresses. Okay, here is the network address, destination network address of the remote network to be added to the routing table. Subnet marks of the remote network to be added to the routing table. The subnet marks can be modified to summarize a group of networks, commonly referred to as the next hop router's IP address. Outgoing interface that is used to forward packets to the destination network. Outgoing interface that is used to forward packets to the destination. Okay, this is the exiting interface. It means outgoing interface of that router. Subnet marks of a remote network to be added to the routing table is the remote network subnet marks that need to be added in the routing table. The subnet marks can be modified to summarize a group of network. Uh, Modified to summarize a group of networks. Okay, destination of network address to the remote network to be added to the routing table. This is something that we need to add in a routing static routes. Dissecting static route signals: IP route static route command 197 destination network address, subnet marks of a destination network, serial 0/0 interface IP address on R2, which is the next hop to this network. Okay, 172.16.2.2. Okay, for example, from here we need to configure if it has to reach to this network from this router, then it has to have a network of a route of a remote network. Similarly, the route of remote subnet, and the exit interface is a serial 0/0, and the next hop addresses is 172.2.16.2.2. Configuring routes to or more remote networks, we can use the following commands in R2. For example, if this router wants to reach to this network, then it has to use IP route 192.168.1.0, 25.25.25.0, and the next exit interface will be similarly 172.16.2.2. Similarly, if it wants to reach to 192.168.2.0 network, then we have to write this remote network and the remote subnet, and the exit interface will be 172.16.2.2. So we have a three routing principle of Jennings. Every router makes its decision alone based on the information it has in its routing table. Okay. The fact that one router has a certain information in its routing table does not mean that other router have the same information. Routing information about a path from one network to another does not provide a routing information about the reverse or return path. So again, let me emphasize this: routing information about a path from a one network to another does not provide a routing information about the reverse return path. So for example, in here, if it has a two route to its destination, but it does not guarantee that routing information about a path from one network to another, does not provide the routing information about the reverse or return path. So I think this is something that we should also um, keep on our mind. Using Gini's three routing principle, how would you answer the following question? Would packet from PC1 reach their destination? Yes, packets destined for 72.16.1.0/24 and 192.168.1.0/24 network will reach their destination. Does this mean that any packet from this network destined for 3.0 okay, 3.0 network will reach their destination? No, because neither R2 nor R3 has a route to 172.168.3.0/24. For example, if this PC pings from here to here, then it will obviously reach to this network and this network, but it does not guarantee that the same path will be followed, because neither R2 or R3 has a route to the 76.3.0/24. So we need to add a route in these routers as well, so that it can move to this remote network for this is the remote network for this router, resolving to an exit interface. Okay. Recursive route lookup. Let's focus on this. I think this is something that is very important. Occurs when the router has to perform multiple lookups in the routing table before forwarding a packet. A static route that forwards all packets to the destination hop IP address goes through the following process. Was the recursive route lookup. Router first match static root destination IP address with the next hop address. The next hop address, okay, I think here we have some